to the customer project defense ceremony today afternoon. Now let's continue with the group presentations. We would like to welcome the mesh networking group to perform their presentation.
Good afternoon, ladies and gentlemen. How was the lunch?
Excellent.
I bet you're ready for another performance. My name is Nguyen Duc Huy, and today I will be your guide to the presentation today. To get the ball rolling, I would like to talk about the agenda for our presentation. First of all, the team will present our project information. Next, we will continue to our project specification. In this, we will discuss the project planning and control, risk management, and communication management. Next, we will discuss how we implement our project and what are the outcomes. Prior to the project information, our team has 5 members: Mr. Tran Ngoc Phu, Tran Duc Vinh, and Duc Vinh, and I. For each individual roles in the project, we will discuss later in the project specification. Prior to the project supervisors, are Mr. Duc Huy and Tran Duc from the Ngo Chanh Duc University of Sciences. Prior to our client, it is FromLabs, the company based in Singapore, founded in 2012, has its branch in Ngo Chanh Duc. Over the years, the company has integrated new technology for better communication and activity process. And Mr. Nguyen Duc Huy is the representative of the company for the project. The 2 main products of the company are InfoSpot and SequenceSpot. I would like to discuss more on SequenceSpot because this was why the project comes to play. SequenceSpot is an application that allows people to have interest in scavenger hunt. The application allows people to create tasks and hit for others to participate in. The participants can communicate with each other in an individual or group chat to exchange information. However, due to some scenario, the distance or environment can be affected, or some scenarios there wasn't any infrastructure to establish. So this is why the mesh network comes to place. Unlike any traditional topology, the infrastructure of the mesh network got carried around by nodes or the participants. Each node can connect directly and dynamically, which create a decentralized network. This is like an advantages of the mesh, as it is cost efficient, and the distance between the nodes can increase. Continue to the mesh. There are 3 characteristics that we would like to highlight. That is self-organizing, self-healing, and multi-hop. Prior to self-organizing, when a node joining the topology, it's automatically joined with the others, and the other can automatically create a path between the nodes. Prior to self-healing, when a node is disconnected due to some events or happens occurrence, the other nodes can figure out the nearest nodes and create maintain the network. Next is multi-hop. This is the advantage that is different from other topology, as it's increased distance between the nodes. As you can see, the A node wants to send a message or package to the it can discover the intermediate node, and the message can be sent through. However, there will be some disadvantages, which are the complexity and latency. Why it is complexity? Because each individual node has to do 2 tasks, which are to send the node and to route the message. Prior to latency, is not quite stable as compared to other. And when the network deployed in a larger scale, it can be a thing to notice. React Native is another technology that we wish to have in our project. With React Native, people can create mobile applications in a cross-platform manner on Android and iOS with JavaScript and React. However, at the time being, and due to the scope of the project specification, it is hard to implement the mesh network with React Native. What I say, we can do it with native modules of React Native, but we find it quite overheaded and beyond our team limitation. That's why this was a change of scope with FromLabs, as the goal was to do a research and testing on the mesh network libraries and implement it in one of the company's products. And the outcomes was to deliver an Android application using mesh network, like one of the mesh network libraries, and a comparison between the other libraries. Next is the project planning that my friend will take over.
Thank you, Kim. I'll take it from here. So I'll be covering the project planning part, which mainly consists of 3 sections. The methodology that we chose, the schedule, and our actual timeline. So first, let's take a look at the methodology that we chose. It was Scrum methodology. The main reason that we chose this simply was because most companies nowadays are using Scrum in their project. So we'd like to have an inside look of how Scrum works and how we could apply that into our project, so we can have a better future at getting a job. Maybe. So by doing Scrum, we also divide our team members into different roles. Here we have the Scrum team, which consists of 3 members. He was a lead developer because he was experienced with a lot of technical skills. And another developer is Vinh, and our tester Phu and Khiem. For the product owner was also Khiem because he knows the requirements, the communication, so he was good at testing too. And finally, the Scrum Master is me. That's why I'm very differently today. So let's move on to the second part, which is the contribution. So as you can see here is the hours that each individual spent on their project. Well, none of us has surpassed 400 hours. For the project progress, which is also the schedule, we divided our project into 8 sprints, which represent 8 months of the research and development project. On our first sprint, it was basically learning for the new stuff and documentation. And on the next 4 or 5 sprints, we started to research for the mesh network, the cross-platform technology, and we also started to build our own product by using the cross-platform language and also one of the libraries that we found. We also execute a lot of scenario testing to test out the performance of the SDKs that we found. And finally, the last sprint was coding and releasing. This is our actual timeline. As you can see, all the activities that we did with the actual dates and month. As you can see here, near the end of 2017, we were implementing mesh network libraries, but however, there we ran into a lot of failures because none of the libraries support cross-platform and the libraries that we could actually implement. So we had to change our strategy a little bit. We started to look for Android development, which is the libraries that support either Android or iOS. Here, on January of 2018, we found HiCap Mesh Network Libraries, which is the library that supported Android, and it was well documented, and the development team was easy to communicate with, and they were very supportive. So that was the reason why we chose HiCap. So that also led to a change of scope. We had the sitting with our clients and we talked about why we changed it from building React Native into building on Android. And follow up with that is all about Android development. And then we execute the scenario test. And finally we deliver the chat app and the project sign up. My friend will show you about the risk management book.
Thank you, Dad. So about the risk management, here with this, the risk we encounter throughout the whole project. We measure this risk based on the impact of the risk on the project and influence. Also, and give the solution for each risk. The first and the second one and the most immense risk to the reflected project. We took a lot of time and effort to build it. And next is because we rely on the network SDK, so the server got down sometimes. Its risk is placed in the medium impact. And the last is the lowest impact on the risk lowest impact on the project. This is the team conflict about the time and place. We continuously change the location when most of the activity. For the solution for the risk. For the first risk, we change from React Native to Android. And for the second risk, we research a different library to fit with the scope. And the third one, we continuously contact with the SDK developer team, and they quickly solve the problem. And the last one, we negotiate within the team to find a location and plan for us to have a location. For the communication management, we have meetings with clients, supervisors, and teams. After the end of the spring, we came to the client to ask to report what we did and ask for feedback, also advice. Furthermore, we discussed on the Gmail and Skype. As for the supervisor meeting, we had a weekly meeting to face-to-face to discuss about the technical problem, and they give us some advice to do the next sprint. Then the team meeting also take place in the weekly face-to-face, and also discuss on the Facebook Messenger about and to show those rules. Overall, the feedback from our player and supervisors and operation are good. But the player asked to discuss more about the technical issue. The reason why we didn't do that because we communicate with SDK development team on FromLabs to solve the problem. And furthermore, we also post the problem on the forum and ask them by email. Mr. Vinh will take. Mr. Kim will talk about innovation and outcome.
Good morning, ladies and gentlemen. I will be the one who will take you to the implementation and outcome. So, as you can see, first off, I will talk about our development life cycle. As you can see, the diagram above displays our development life cycle. We start with the implementing the project first. We're integrating the library into our project. We're coding the function based on the APIs it provided. And then right after that, we're testing our results. The development have to test themselves, but we not test to detail, and we transfer it to our tester team to do it. And right after that, if there is any bug occur, they will report back to our developer to fix it as quick as possibly can. And right after that, we come back to the implementing stage. So that's our life cycle to develop the application. So first up, the implementing stage, I would like to tell you about our application workflow. As you can see, first off, you have to make sure that you open either Bluetooth or Wi-Fi on your devices. For what? To use the Bluetooth or Wi-Fi protocol to communicate between nodes. And right after that, you need the internet connection for one-time registration. Why do you need this? Because a certification is a must for an offline communication. And to do this, you need internet connection, and your registration will be made sure. And right after that, you don't have to worry about the certification again, because until the next expiration, you don't need to register your app again. And the expiration for token is 24 hours in development mode and 1 month in production mode. And right after your registration, you will be free to send your message through nodes. But before that, there is a constraint that to be made sure that the devices must be found within range before you send your network. You send your message. And if you lost your nearby devices, the lost device will not be received the message. And in this project, in this application, we divide the message into 3 types: the plain text message, the picture message, and the video message. I am the one who take responsible for the plain text message and the video message. And for me, the most difficult thing among those 3 is the video message. Unlike the plain text message and the image message, and after the user receive those, they can be displayed on screen right away. But for the video message, I have to turn it into byte array and send it through the high protocol. And when received, I have to store it into the storage, and I get the UI and display it on your screen. So this is for me the most difficult thing in the project is to implement the video sending message function. And after that, so Mr. Vinh will talk about the image message implementation.
When I develop sending message function such as image, I got some problem about technical knowledge, such as binary to byte. But however, with many support from technical leader and supervisors, I would be able to cover this task. And After finishing any functions of the application, we will test the application manually, which means we run the APK of the application on some smartphones and try to scan all the instances or send message. And if we found out any bug, we will put the log or use the built-in functions of Android Studio to verify and fix us. And when we talk everything will okay, we will send the APK of the application to tester team for testing period. And now we'll talk a little more about this period.
So I will also be covering the testing part, which is firstly is what needs to be tested. Well, as you can see, the most important thing was scenario testing. We have to test, for example, node client capacity, throughput performance, roaming, and some other functions like multicast, unicast, and quality of service. So let's show you some details of how we tested our SDKs. First would be the functional test. We executed some, as you can see here, there are some simple testing first. For example, unicast, we test whether the SDK have the most basic function of a mesh network. And we also test, for example, can a user create a contact list of other users? It's just a user-friendly kind of function, but it's kind of important. So we also tested that. For the scenario testing, also called the performance testing, this is where we have to gather the team together because we need a lot of devices to actually perform this test. For example, we test using either Bluetooth or Wi-Fi to communicate to configure a mesh network. We also test the time delay between the nodes in terms of communication. So the next slide will show you how we actually execute the scenario test. Here are the two types of tests. For example, the data throughput while broadcasting messages. We have at least 3 devices, and one of them will start to broadcast the message to the others. And we don't only just send the basic text message. We send a lot of bytes to see if there are lots of if there are any packages will be lost while transferring a lot of bytes. And the next test is the multi-hopping test. We have like 3 to 4 devices, and we will send message from one device to the other by multi-hopping through the other. So we also send a lot of bytes, a huge amount of data to see if there is any loss of packages. So now we move on to the bug fixing section. My friend will be covering this part.
Yes, as I said, after finishing any person and we found out any bug, we will try to review the code and to this bug to be suitable for the person we want it to perform. And that's it.
I would like to talk to you the test results of our team. First off, I will talk about our scenario first. I'm using mesh network to sending 500 packages between devices and using Bluetooth protocol and Wi-Fi protocol. And I do it five times. So this is the Bluetooth sending, after sending 500 packages. And the orange one is the maximum time for each package to arrive to the other node. And the blue one is the average time for each package to arrive to the another. And the gray one is the minimum time. So all of the time will be counted as a millisecond. So as you can see, as the graph shows, the maximum time for each package. I can say for the true 5 test cases, I can say it approximately 1 second to another node to receive the message. Same with the Wi-Fi protocol, but unfortunately, the Wi-Fi protocol is more faster than the Bluetooth one. I have asked the Mr. Andre Francisco, who is the founder of the FromLabs SDK, and he told me that this is the protocol technology itself. It's not related to his library. It's related to the Wi-Fi and Bluetooth characteristic. The Wi-Fi will always be faster than the Bluetooth. In this demo video, I would like to show you two parts. The first one is our product by sending type of messages, and the second one is our measurement, how to capture the time of each package to deliver when it delivered to another package to another node. The product one. So first off, with the unicast, to make sure you scan another devices within range. Right after that, you are free to send message. You can send plain text message. You can send emoji. So with the image, would be the same. First off, pick the image that you want. So the hardest part is the video one, as I said before. I try to send a video with the small size as possible, because it took too much time to transfer. So this is multicast. It took time to scan through all the nodes. Rather than you keep sending your message that you want. All the nodes are received the message from one node. Same with the sending image. As you can see, all this message comes from this device, and those two can receive it. It depends on the size of your file. The message could be delivered to each node, fast or slow, based on the size. This time I use another small video. So as you can see, this device is receiving this video slower than the other one. So this is how us measure the packages and the time of each packet arrive to another node as the requirement. So first up, I send a 24-byte message to this instance, and this is the total time to from when it's sent until it received by the another node. And I send it 500 times. So I capture all the time of each package, and then I have a statistical table like you see before. 500, this is the time of the last package. This is Wi-Fi. The previous one is the Bluetooth one, and this is the Wi-Fi. It's absolutely fast. As you can see, the time instantly same. So 500 packages within few seconds. And the Bluetooth between three devices, and you will see the difference. So as you can see, this is two different nodes. It will send not sequentially, but $500 for each node. So we have total 1,000 packages. As you can see, total time is 4,000 milliseconds. The Wi-Fi is faster than the Bluetooth one, so it's no matter for you to send among multiple devices. The time was too small. Just a few seconds and it will deliver 500 packages to each node. And there is a special case. Let's say while sending package to another among three nodes, what happens if one node is disappeared? So as you can see, only one node left. This is another node, and this is another node. But at this time, this node is vanished. And from now on, only this node will receive the packages. It keeps sending the message to the existing node. Only this node receives the message. Thank you for your watching. Before that, we will show our acknowledgement to, first off, to special thanks to our team members, to each member in my team for standing together until the end of this interesting journey. And that's why special thanks to Mr. Nguyen Duc Huy and Mr. Ngo Chanh Duc for helping us throughout the project. And special thanks to Mr. Tran Duc Vinh, is our client, for support. All the support for us. Mr. Our project coordinator, Mr. Campbell and Mr. Bui for give us an opportunity to experience this interesting project. And special thanks to our ITEX office staff for always caring about us and keep telling us to apply the document on time. And last but not least, we really appreciate Mr. Andre Francisco, the founder of the HiLab SDK, the one who always answers all of those questions about the HiLab SDKs. He's the one who helped us too much in this project. Thank you so much. It's time for question and answer.
have the result of this kind of scenario test here. For example, maximum distance between two nodes for the Wi-Fi connection or just Wi-Fi Bluetooth connection.
Yes, we have. The maximum distance between two nodes that we have measured we did the measurement in the University of Science is here, and the maximum distance is we approximately 4 floors. I stand in the 11th floor and we stand in the 7th floor, and then it ran to the 6th floor and connection lost.
Prior to the actual measure, actual metric for the headlights, the actual distance is about 60 meters in diameter. We tested in the wet area.
So does it depend on the library or not?
This depends on the libraries and Bluetooth or Wi-Fi.
So this is a result from the pre-library.
Prior to the other two, which are underground and principally the diameters. The diameters of the result is 120 meters.
So are there any document you talk about this?
Yes, we have it in our test results.
Okay, how about the scenario test for the multi-hop scenario? Could you show me the scenario for a multi-hop?
For the multi-hop, unfortunately we did it, but we just saw it in the document, not in the demo video. That we
Just define a scenario.
Yeah, the scenario is quite simple. A and B stand in each spot, and A and B cannot reach each other, and then there are C between A and B, and then A can see B and C, and A start to send message to B through C. I can say C is the bridge to connect the A and B, not to each other, and I have tested and it completely success.
Is it a multi-hop scenario?
Yeah, I think it's multi-hop because A and B cannot see each other, and there are multiple nodes stand between them and the message. If the message, if I want to send a message to B, it must go through B, C, D, and E, F to B1. This is the each hop jump, and the high block is supported maximum 5 hops jump.
Five hop jump.
Yeah, 5 hop jump.
So I mean that I want to send message from the A to C, but too far. A is very too far to C, so I cannot send message. And the node P is here in the middle of A and C. So B, this type of grid, B will receive a message.
Yeah, B also received the message.
So only B know the message. So if I'm not B, I will know the message as well.
Oh no, you have to make sure that your application must have the same app identifier and token. This is the security problem. If all the application in the mesh one have the same app identifier and token, as I said before, that you have to certificate your app with this registration.
So that means the owner of the node B do not know he received the message. He just a brick. Is it right?
He does know because the Hive SDK can only scan the instances within range if all the instances have the same app identifier and token. So if you say A and C too far and can see each other and B appear, and A can see B and C, so which means A, B, C have the same app identifier and token. So A can send the message to B, but C is the one who received it and transfer it to B.
So can you send a message
between two nodes with that are able to see the map?
Yes, you can. However, if the distance is very far between them, it is not to be.
How about the throughput for the video?
Yeah, the throughput and the latency, I have asked the founder of the SDK. They said the library is created, is the original purpose of this SDK is oriented is to make a production, not for research. So if you want to know those something like latency or throughput, you have to find out the library. This library does not support this. This is only for production, not for the research. So,
But your application can use the library and measure things.
yeah, the main.
I agree, it's not the library's job to do the measurement, it's the application that is using the library.
Yeah, because the APIs that the library provided to us is quite abstract. They only provide those APIs for use, and I have to think the benefit, appropriate logical flow to capture the time of each package when it delivered to another node. It's not the job of the library. I did it by thinking of own logic, and it's difficult.
Why it's difficult?
No, the thing that you capture, you measure the time of each node to deliver to another node is difficult. And it took me a while to think the solution to capture this time that you can see in the demo. The library doesn't support this, so I have to think it myself.
So we have comparison table between three SDK.
We'll get the comparison table.
What does it mean when you say it doesn't support sending video? Slide 39.
Is the other
library sends data.
Yes.
What difference does it make whether it's data, whether it's video or music or text?
We tested this one on the existing application of libraries.
Okay, so it's not really the libraries. It's what the test application does. Oh. So that's not correct. It doesn't support sending video. So the correct statement is doesn't have a test tool to test video.